Good afternoon, ladies and gentlemen. I'm Junyu from Peking University Third Hospital. I'm really glad to be here for this oral presentation. My topic is Dystrophinopathy in paraspinal muscle of AAS patients, a prospective cohort study. And there's nothing to disclosure. So AAS affects 2 to 4% of the children under 16 worldwide. And there's etiology remains unknown with plenty of research. So some scholars propose that genetic mutation, SMP, bone or cartilage development, or hormone endocrine imbalance may be the cause of the AAS, but it's still unknown. So paravertebral muscle is an important research direction. And Fiedler, Kostler, and Wenchenberg et al., they all propose that there's some correlation between the paramuscle nerve and muscle pathology changes between the AS and the muscle changes. So in 2015, Lucino et al. Reported cases of AS patients with paraspinal biopsy indicated that a high likelihood of core myopathy, but it didn't show the typical symptom of decreased limb muscle strength or limited respiratory muscle function. Hypothetical explanation is that maybe AS a particular kind of neuromuscular disease which only affect the paravertebral muscle function. So we think that's a really interesting point. So we conducted a study, 40 patients with AS, 20 patients with CS, and 20 patients with degenerative disease were included. And we collected the imaging data and paraspinal muscle biopsy data, especially the dystrophin. So we proposed a SOP from biopsy in the OR to the pathological changes result in the lab. So from the baseline information, we can see that we try to control the sex, height, Cobb Angle, and Nash-Moe classification comparable between the groups. And by comparing the AS to the CS group, we found that dystrophin were decreased or absent in the AS group significantly. And by comparing the AS and the degenerative spinal disease group, we found dystrophin were decreased or absent in the AS group significantly. And here is the histological changes of the patients. So we further compare the Nash-Moe subgroups between within the AS group. We found that dystrophin 2 expression in the convex side was abnormal or absent significantly in higher group types. And the dystrophin 2 staining on the concave side shows the positive correlation with Cobb Angle, indicating that reduction in dystrophin 2 staining in this side was related in the increase in the Cobb Angle. And that's all for my study. And by comparing the AS with SDD, we just highlight the deficiency of the dystrophin in AS patients. So is the decrease in the dystrophin a cause or effect? Then we compare the AS with CS group. And CS is not accompanied by the loss of dystrophin. So maybe dystrophin deficiency a cause of the AS. And we further compare the compare the correlation between the dystrophin deficiency and the Nash-Moe types and Cobb subtypes. We found that maybe dystrophin 2 play a major role in this pathology. So dystrophin, it's a structural protein maintaining the membrane integrity and circular hemostasis, and dystrophin 2 is mainly responsible for the connection with the extracellular structure. So some DMD patients may even have scoliosis due to spinal muscle involvement in the later stage. So unlike the traditional DMD, our study, the patients, the pathological changes only in the paraspinal muscles and causing asymmetrical spine traction so that to cause scoliosis. So we speculate that maybe some of this AS, a special neuromuscular disease that only affect the paraspinal muscle. And we have some limitations. So in the future, We hope that a study better control the confounding factors, and a multicenter large sample study could yield better results. And thank you very much.
Thank you so much.